Let's take a look at lesson 1.6. What are the chances? We will be learning about basic probability in this lesson. This is on page 75 of your textbook. If you look down to the middle of the page, under where it says class, they describe probability for us. The probability of an event occurring is a description of how likely it is that the event will actually happen. Probability can be described using a number ranging from 0 to 1, a percentage from 0% to 100%, or using words like impossible, unlikely, even chance, likely, certain. Look at the examples that are given on this line here. For example, on a die, you have 6 sides. Each number has 1 chance of occurring, so it's fairly unlikely that any given number will occur. On the far right of this line, we have a hand in cards. The hand consists of 8 and king, 4 8s and 1 king. The chances of pulling an 8 from that hand are pretty high. Something like flipping a coin, which is in the middle, has an even chance, or a 50-50 chance. Going to page 76, we start with our questions. Number 1 says the probability of rolling a 4 with one standard 6-sided die is 1/6, because there is one side with 4 dots and 6 sides total that could be showing when the die stops. Write this probability in equivalent forms as a decimal, rounded to 3 places, and as a percentage, rounded to 1 decimal place. So first of all, we want to take 1/6 and convert it into a decimal. How do we do that? The easiest way is to take 1 divided by 6 into your calculator. Go ahead and do that. You should get 0.167. Can't read my calculator. That's the first part, that's the decimal. They then ask us to convert that to a percentage. To convert to a percentage, we can either multiply by 100 or move the decimal 2 places to the right, giving me a percentage of 16.7%. Number 2 says write a sentence describing the percent chance of rolling a 4 with one standard die. To roll a 4, you have a 16.7% chance of rolling a 4, which means that rolling a 4 will occur about 16.7% of the time. So we could say rolling a 4 will occur about 16.7% of the time. Moving on to question number 3. If you roll a die 300 times, how many times would you expect it to land on a 4? What was the probability? We know the probability from the first question was 1 out of 6. If I take 1/6 times the number of rolls, the 300, you should be able to do that in your calculator. 1/6 times 300 should be 50 times. Number 4 asks, how sure are you that you'd get the number of 4s you'd expect in 300 rolls? So how sure am I that I'm actually going to get 50 4s when I roll the die 300 times? I'm not very sure at all. The odds of me getting exactly 50 are pretty slim. I may get somewhere near 50, but unlikely that I'll get exactly 50 4s. When we're thinking about a situation in which we'd like to compute some probabilities, we use the word outcome to refer to different possible results. For example, when you roll a single die, there are 6 distinct outcomes, the whole numbers from 1 through 6. When a standard coin is flipped, how many different outcomes are possible in terms of which side lands face up? How many outcomes are there for flipping a coin? Well, there's heads or tails. So when we flip a coin, we have two possible outcomes. On page 77, they continue with this exploration. Based on your answer to question 5, what is the percent chance that a single coin lands on heads when it's flipped? How many heads are on the coin? If it's a fair coin, there's one. You can buy two-headed coins, probably on Amazon, but we're not going to do that today. How many total outcomes were there? 2. What is that as a percent? If something is half off, it's what percent off? 50%. Number 7 asks us to write that same probability as a fraction between 0 and 1. So the way I originally had it written is 1/2 is a fraction between 0 and 1. Describe the likelihood verbally. The likelihood is that it will be heads. One time out of every 2. The box here tells us exactly how we computed probability. You'll see it's what we've been working with. The probability is found by taking in the numerator the number of ways that an outcome can occur and dividing by the total number of outcomes. So for example, the probability of rolling a 4, there's 1 4 out of 6 different numbers, so the probability of a 4 is 1/6. This p parentheses rolling 4 is written in probability notation. It just means probability of rolling a 4. So back to our coin, which we have a 50-50% chance of getting something. If I flip a penny 80 times, how many times do I expect it to be heads? Well, I would expect it to be heads 1/2 of 80. What is 1/2 of 80? 40. I would expect to get heads 40 times. Would you definitely get the number of heads that we found in question 8? Would we definitely get 40 heads if I flipped it 80 times? Unlikely. It will be somewhere close to 40, but it's unlikely that you will get exactly 40. Turn to page 78. They refer back to the probability diagram on page 75. It's talking back to the card hand we saw. It's a good hand in poker, 4 8s. If you were to randomly pick a card from that hand, what is the probability that it would be an 8? How many 8s are there? Well, first of all, probability notation is probability of getting an 8 or choosing an 8. We could say that. How many 8s are in that card hand? There's 5 cards total. How many of those cards are an 8? 4 of them are an 8. They asked us to write it as a fraction between 0 and 1. Then they ask us to convert that into a percent. As a decimal, it would be 0.8. As a percent, that would be 80%. So number 11 asks us to use that then in a sentence. We would say, we expect an 8 80% of the time. So let's recap and talk a little bit about what types of probability we've been looking at. Each of the probabilities that we've calculated so far can be found without doing any actual experiments. We know for sure that when we roll a die, there are 6 possible results, and only one of them is a 4. This type of probability is known as theoretical probability. Our calculations are based on observing how many outcomes are possible and how many fit a certain criteria, and then assuming that each of the outcomes is as likely as the other to occur. If a die were strangely weighted to make the 4 more likely to come up, then our probability calculation would not be accurate. In that case, we might look at empirical probability. Empirical probability is what happens when I actually do the experiment and determine how many times I get a 4, or whatever it is we're looking at. We could roll the die a bunch of times, let's say 100, and record how many times 4 comes up. If we then divide the number of times we got 4 by the total number of rolls, that would give us an approximate percentage of rolling a 4. That would give us the empirical probability. Theoretical is what should happen. Empirical is what actually did when you did the experiment. You should be now ready to work on the group work for lesson 1-6.